This lesson is designed to help you out with problems that look like this, where you have a couple of right triangles, and you're going to have to use Pythagorean Theorem, a squared b squared c squared, on one of them, and right triangle trig, or SohCahToa, on the other one. Now, the biggest piece of advice I could give you is look and see where the x is at the beginning, and understand x is going to be the last thing you find. So you're not going to start here. You're going to have to start with the triangle over there. Let's see how this works. Okay, here's example 1. And when you're looking at a triangle like this, or really there's 3 triangles, the left one, the right one, and then the whole thing. First thing you see is that you got your x over here on this left triangle. What that means is this triangle over here, this is not going to be the triangle that we start with. It's going to be the triangle that we finish with. So we don't want to even start with that triangle. What we want to do is look at this triangle right here, which is also a right triangle. Now what we have here is we have a bottom side and we have the hypotenuse. When you have 2 sides and you need to find the third one, which will be that up and down line there, we're going to use Pythagorean Theorem. In this case, remember that 27 is the C, here is the A, and what we don't know, that's going to be the B. So we'll start out by saying 16 squared plus B squared equals 27 squared. Now we're trying to solve for that B, so you minus 16 squared on each side, and we get B equals, oh, and of course this is still B squared. Then to unsquare the B, you have to square root both sides, and then that gets rid of this. So B is 21.75. Okay, what that means is now we know this length right here is 21.75, and we can ignore the right triangle while we work on just the left triangle. We're trying to find the hypotenuse right here. All we have is the side furthest away from that angle. Remember, that's always important. So that is the furthest away side, so that 21.75 is our opposite side, and that is our hypotenuse side where the x is. So this SohCahToa problem has an O and an H in it. That means it's going to be a sine problem. And you got to know how to do that. So start out by writing sine, and then next to it you write the angle, which is 55, equals opposite over hypotenuse, so 21.75 over x. And remember, when your x is on the bottom of the fraction, all you have to do is swap spots with the trig. So these two things swap spots, and in your calculator you just have to put 21.75 over sine 55. If you're using this calculator, the mode button is here. Make sure it is in degrees mode, not radians mode. If you're using a calculator you downloaded on your phone, sometimes they come already in radians mode. You don't want that. So I'm going to hit the fraction button and put 21.75 over sine 55. And when I hit enter, it should give me the answer 26.55. That is the length right there. Okay, and example number 2. The biggest difference on example number 2 is that you see the bottom, the entire bottom is given. So they say 19 is the length from here to here. Okay, so that's going to be a little bit of a problem for us. Still x is right here, which means we're going to not deal with this triangle to start out with. We're going to deal with the right triangle. So we're dealing with this one. Anyway, here's the situation. You have this angle right here, which is 39 degrees, and then you have the opposite side, which is 6. Now, what we want to do is when somebody says this whole length over here is 19, we want to say how much of it can we say is right here. Like if this was 9, well then we would know this is 10. So that's where we're really going to put our x right there. Find out what this is. Maybe, hey, if this was 12, maybe that would be 7. And this, as you can see, it's not Pythagorean Theorem. Pythagorean Theorem only works when you have 2 sides and you want to find the other. This is a sine, cosine, or tangent problem. Now from this angle, obviously the 6 is the furthest away side, which makes it an O. The x down here is the closest side. It's not the hypotenuse, so we're going to call it the adjacent side. And we have an O and an A. So that makes this a tangent situation. So go ahead and write tangent 39 equals opposite, which is 6, on top of adjacent, which is x. And again, you've got one of those trig functions with x on bottom. So that means that x and that trig function swap spots. So x equals 6 over tangent 39. And then this is what I'm going to put into my calculator. So what that means is this is 7.41. Remember, the whole darn thing down here is 19. So what I've got to do is take 19, take 7.41 away from it to figure out what is the length from here to here. So in my calculator, I'm going to say 19 subtract 7.41, and it's going to say 11.59. So that means this is 11.59. And now that you're here, you actually don't need any of this right triangle over here anymore. We just need that left triangle over there. So like all this stuff, we did some good work, but we're done with it. Now we're over here. All right, here you have the bottom of this triangle is 11.59. The right side is 6, and those are the legs. And anytime that you have two sides of a right triangle and you need to find the third, that is a Pythagorean theorem. And we'll call this A. And we'll call this B, and then the hypotenuse is always C. So 11.59 squared plus 6 squared equals C squared, or X squared. All right, throw this in the calculator. So 170.3 equals X squared. Square root to unsquare, square root. That will cross off. And you will just have to put the square root, 13.0